In this video, I am going to explain the theorem. A connected graph is a tree if and only if every edge is a cut edge. So here, what they are saying is every graph will be a tree. When every graph will be a tree? That is when every edge is a cut edge, then that graph is called a tree. Okay, so as we all know, cut edge means what? From the graph. Okay, if I have a graph like this, consider this graph. Okay, so here is an edge E. I mark this edge as E. Okay, so if I want to say this edge E as a cut edge, then what is the condition that E should satisfy? That is, even after when I remove this E from this graph should become disconnected. Now this graph is connected. So if I remove this E from this graph, I will get a graph like this, right? So now this graph is, after eliminating this edge, I got a disconnected graph. So if I remove an edge from a graph, I should get the graph disconnected. Then you can say that particular edge as a cut edge. So here, a connected graph is a tree. When it will be a tree? If and only if every edge is a cut edge. Or if in a graph, if every edge is a cut edge, then you can say that graph as a tree. Okay, that's what the meaning for this theorem. So let's move on to the proof. So here, let in the first line you are taking a graph. You are taking a graph and the name of the graph is G. So let G be a connected graph. You are taking a connected graph. Now in the next line what you are doing is, this is an if and only if theorem, no? So here you are assuming this. Okay, by assuming this you are going to prove every edge is a cut edge. Okay, so that is what going to happen in the next few lines. So that is, assume G is a tree. Okay, assume G is a tree. So in the first line you have chosen G is a connected graph. So you are assuming this G is a tree. Okay, and you are going to prove every edge is a cut edge. In this tree, every edge is cut edge. That is what you are going to prove. Okay. Okay. So now, from our assumption, what you can say, from our assumption we have, you are assumed that G is a tree, right? So, if it is a tree, then it is obvious that G is acyclic. Okay, if there is a cycle, then you could not say that graph as a tree. Okay, so in our assumption we have G is a tree. So you should not have any doubts that in our assumption we have G is a tree. So you can say that G is acyclic. Now you are considering an edge here. The name of the edge is E. Okay, so only if you have edge, then only you can say that every edge is a cut edge, right? So to prove that, you are choosing an edge. The name of the edge is E. Now to prove, this E is a cut edge. Now since G is acyclic, so here since in our assumption we have G is a tree, so as we all know, tree is always acyclic. So here G is acyclic. E is contained in. So it means, what does it mean? This, our edge is contained in no cycle of G, right? So now, therefore, by a theorem, we have a theorem, an edge E is a cut edge of G if and only if E is contained in no cycle of G. So here you got E is contained in no cycle of G, right? So by this theorem, you can say this edge E is a cut edge of G. So that is how you proved the first part. Now you are going to prove the converse part. In the converse part, you are assuming E is a cut edge and you will prove G is a tree. Okay. So for that, okay, what you are doing is suppose G is not a tree. If G is not a tree, then what does it mean? Then G contains a cycle. If it is not a tree means then there will be cycle, right? So that is what you are written here. Now we know that again you are bringing another theorem here. An edge E is a cut edge of G if and only if E is contained in no cycle of G. In our assumption we have E is cut edge, right? So here you got E contains a cycle. But already we have a theorem that E is a cut edge. If E is a cut edge means then E contained in no cycle of G. That is, E should not be in the cycle. Then only you can say E is a cut edge. But in our assumption we have E is a cut edge. But here you are saying that in G there is a cycle. So here you are getting a contradiction, right? So that is why, which is contradiction to our assumption, this assumption. So therefore we get, here you took G is not a tree, right? So that is wrong. So here we get G is a tree. So finally you proved that, right? So hence the proof.